then let us.
I was here on Friday last week.
So you can either get the filled-in copy of the rest of the notes from someone while we're working through other examples, or you can get them from Canvas and look at the class video to see the rest of those notes as well. Yes, you can. Do you have those notes? Or do you need them? Right. Words for division. When we think of word division, what word is division? Dividend. I think that's how you spell it. Mia and then Hungarian. Quotient.
So next time we hear the word division, right? On divide.
Okay. Any other? I don't remember what all we said for multiplication, but look at your multiplication and see if there's something that you can say you have this
What?
Yes. For multiplication, we did say that, so opposite of that would be divide. That's splitting off. Okay. This is kind of hard because it's not that bad. I'll give you a couple. Sometimes we use the words like over. When you think about fractions in general, you wouldn't use the word fractions, but if you like see fractions, I see 2/3, I know I'm dividing. And then you'll also see the word if you think of some other ones we can add to it. And I think I said if you have any other words that we didn't put from multiply, you can say those too. I don't remember what all we said, and my mind is kind of split between both classes. But if you want to add more words to those, then let me know. I think we kind of talked about this when we were doing the properties, that we will no longer be using these symbols. We'll use the dot or the parentheses, and we'll use just the fraction itself for division. So just keep that in mind going forward, that you won't see those. And you'll see them less often. Right? And then there's a couple of these that, some of these are repetitive of what we saw before, but they mean a certain thing. So parenthesis phrases are all of the quotient, sum, product, difference. With the word of, sum of, difference of, product of. Anytime you see those words, you can almost like group the next set of words together, like in parentheses. So if I say the sum of everything after those words, I'm adding together. If I say the difference of everything after those words, I'm subtracting together. Same thing with product and quotient. You usually see sum of like x and wherever that and is, those two things are what you're doing. And then some two-in-one phrases. This is really for subtraction. If you see the words less than, anytime you see the words less than, it'll be like 8 less than x. you're going to take whatever comes before the word less than and move it to the end. Since it comes before the word less than, would go towards the end. There's not a whole lot of other ones. Sometimes they'll use just the word less to like trick you, but that's not a turnaround phrase. Decreased by is not a turnaround phrase, but you just have to pay attention to what is being decreased by what, because sometimes that. Now to actually get into some examples, we're not going to do all 6 of these together. We're going to do 3 together, and then I'm going to let you guys try some. Let's start with number 2. First, we're going to read it. See if there are any operation words or words that tell me to add, subtract, multiply, divide, and then try to write an algebraic expression. So 10 less than the product of 7 and f. What is this telling me to do? Subtract from what word?
Less than.
Less than. And what else? Product of. That means we're going to multiply these 2 things together. Less than is that turnaround phrase, so 10 has to go at the end. So already you know we're subtracting 10 instead of the other way around. And then the product of 7 and f. We can put those right next to one another since they are multiplying. If you just have things that are like 2, you won't see the dot in the middle, even though it's really there. You'll just see them next to one another. And then moving forward, anytime you see 2 things next to one another, know that they are multiplying. Questions on that one? Seven less than a number squared. What is it telling us to do? Avina? From what word? Again, yes, we're going to move that 7 at the end. And then, is there anything else it's telling us to do? Square. Even though it's not one of our operation words, we do have to take into consideration that it's telling us this is square. It's raised to the 2nd power. So times itself 2 times. A number with the x. Yeah, so anytime it says a number, think about that as your variable. It's not talking about an actual number, and you can call that variable whatever you want. If you like x and you're an x person, that's fine. If you rather use your letter of the alphabet, whatever your name starts with, that's fine. So how would we write this? So we're taking that number, we're calling it x. If you want to call it something else, that's fine. Then we're subtracting something. Yeah, I did see your hand, so I'll let you choose the next problem we're going to do. This one? 4. Okay. So for 4, we have the product of a number and 10 increased by 1. What is it telling us to do there? Multiply, and what word tells us that? Yep. So a number and 10. Anything else? And that tells us to do what? So we have a product of a number and 10. We need to multiply those two together. And we are increasing it by 1. How would we write this? So again, you choose whatever variable you want. Unless it specifies which variable it is, then you can choose whatever variable you want. Anytime you are putting numbers and variables together, even though it says a number and 10, we usually put numbers before the variable and then increase by 1. Questions on that? It may not take you the whole 5 minutes, but I'm going to give you the next 5 minutes until 56 to do 1, 3, and 6. You can talk amongst the people at the table for ideas, check in with them. If you have questions, I'll be walking you around. Feel free to raise your hand and ask if you have any questions. Tell me what you got, and then I'll go through and highlight. You guys can say that loud.
Plus 6.
And 6. And plus 6, yes. So here it says more than, which means adding. That's all you have to do. For number 3, this one you guys might have different things. So I'm trying to get different numbers. 2/3 times 2. 2/3. So did you write it with that or without it? With that. Okay. So some of you wrote it like this. And moving forward, if you have a number and a variable, you don't really need that. You could have just written it like this. Like how? Like B. So anytime we are multiplying numbers and variables, we put that number first. The order doesn't matter. But in math, we prefer that the number comes first. I'll say it like that. Another way you could have also written this is if you put v in the numerator. The reason why this works is all numbers and variables are really fractions. There's invisible 1 underneath. If v has an invisible 1 underneath, then I can multiply these two fractions together, multiplying across, get 2 over v. So you can write it, I would prefer either of these two ways, and let's try to only use this if there's like multiple. And then number 6. Yeah. 2x over 3. Mine is kind of crooked, but it should be more vertical. I didn't really see this in here. Last class, or not really, but second period, some of them are writing it like this. Oh, it's a mess. And we just want to avoid writing it horizontally because we want to keep it in that fraction form. Now that that's wrong, it is technically not what not what you're going to see. So some of you were confused by the word twice. That is multiplication. Some of you changed it to square. So just keep those two separate. A square would be your exponent, twice would be multiplication 2. questions on any of those before we continue? Usually when you're going from words to algebraic expressions, there's really just one way to write it. However, when you're going from expressions to words, there are so many different ways to write it. That really being because there are so many different ways to say the same word. I can say times, multiply, multiplied by, the product of. So if I don't write it the same way as Kat does, or Kat doesn't write it the same way as Dante does, that's okay. If you guys have variation, that's fine. As long as it makes sense. All right, we're going to do a couple of these together, and then I'll let you do the other two. We're going to do 8 and 10. Okay. So first, we're going to look at this and see what all operations are happening. To keep in mind those words for right now. So what all operations are happening in number 8? Multiplication. And somewhere in our wording, we need to have something that says they're multiplying, something that says they're adding, and something that says the z is being squared. Okay? I'm going to give you 2 ways to write this, and then if you want to change any of those words, you are more than welcome. I'm going to give you the shortest, easiest way to write it. Anytime you have numbers, you can write out the number, or you can just put the number. So I can say 5 times. Sometimes when you have variables raised to a power, you can write it as that. Z raised to the second power is z squared. You could also sometimes just write times z squared plus 16. That would probably be like the shortest way to write. Now, if you want to write this long way too, you can, but don't feel like you have to. I'm going to write this down here. This is probably the longest way to write it. And if you like this way better, that's fine too. If I started this off by saying something about the sum of, because I know I'm adding this term and this term, then I know the next 2 things I'm adding. Then I'm going to say the sum of the product of now I need to say what 2 things I'm multiplying. 5 and z raised to the second power. So this tells me what 2 things I'm multiplying. Now I need to say what 2 things I'm adding. So the sum of the product of this and 16. That would be me putting all of those operations together in a much longer wording. So some variation of this or this is what you need. If you want to check to see would this work, just let me know. The reason I use sum of first is because overall both of these terms are being added together. That would need to come first before anything else. For number 10, what operations are we doing? Okay.
A number 1, then.
Don't tell me the words right now. Just tell me what math operations are we doing.
Addition, subtraction, and multiplication.
Multiplication. Are we using subtraction?
No, sorry. Division, I meant.
Division, yeah. Okay. And then, since you had that example ready, go ahead and tell me what you were going to say for wording wise.
Sorry. A number more than the product of 6 and B divided by 2.
I'm gonna pause right there because everything you have so far is good. I put the hashtag pound symbol for number just because I don't have space to write the word number. You can do that. So far this makes sense. A number more than you're adding the product of 6 and B. Okay, so we know what two things we're adding. You know what two things we're multiplying. Now, if I just say divided by 2, if I read it, a number more than the product of 6 and B divided by 2, that makes it seem like just 6B is being divided by 2.
Parentheses.
You would have to use one of your parentheses phrases, like quotient of. Is there another way I could reword that divided by 2 to say that everything is being divided by 2? If I add the quotient of in the front, everything there is still the same, and then at the end I say and 2.
The 8 plus ahead of the 6
In
Yeah.
that order doesn't matter. Another way you could have said this, instead of putting the quotient and then the and 2, is a number more than the product of 6 and B all over 2. Because that would tell me everything is being divided by 2. While you guys are working on 7 and 9, I'll put up the longest way to write 10. Do we have questions on 10 before I let you do that? Not 5, we'll say 3 to 4. So between 9, 11, and 9, 12. Try and see if you can go ahead and do 7 and 9, and let me know if you have any questions. And we'll go over those when we. Yeah.
The one where it says the sum of the product. Never mind. Okay. Sorry.
I'm going to keep this on the recording, but. Let me get your attention back up here. And then, before I ask for your 7 and 9, I'm just going to read this and kind of talk about why there's some differences going on. the longest way to write this. The quotient of the sum of a number A and the product of 6 and a second number B and 2. So the quotient of is, I'm dividing all of this into. The sum of, I'm adding this and this second part. And then the product of, I'm multiplying 6 and that t. So just keep in mind, if you're using those words, sometimes too many of them get kind of mixed up, and then you have to remember all your ands and what's doing what, so just be careful with those. Anyone want to share their number 7?
The product of 3
and now if you just said 3 times x raised to the power of 4, that's fine too. Anyone want to say theirs to make sure theirs is right? And then for number 9, anyone want to share that one here? 16 times x minus 3. If yours is more complex than that, that's okay. Anyone want to check their answer? Over here. Yes. The x and 16 works, but if you wanted to switch it to 16 and x, you could also do that. As long as you know that here 16 came first, that's fine. On this page, we're going to do or translate some real world problems. We're going to do 3 together, and then I'll let you do the other 2. So we're going to start with number 11. With all real world problems or scenarios, read it, highlight or underline anything you feel like is important. That could be any numbers you see, any variables you see. What is it asking for? Mainly those right now. If you need or want a highlighter, I do have some back there. Right, so I'm going to go ahead and read it, and then I want you guys to figure out what is important here. Mr. Martinez orders 250 keychains and printed with his athletic team's logo, and 500 pencils printed with their website. Write an algebraic expression that represents the cost of the order. What is important here? Numbers of
The numbers of how many he got,
okay, so 250 keychains.
and the fact that they want the cost of how much everything is, not just the total number of things he bought.
Correct. Correct. So that the end goal is really important because that helps you know, am I looking for how many things he got, or am I looking for cost?
the cost.
Yes. That.
So, how do you know how much it will cost? Like, one for each key and pencil, or what?
So we're not solving it, but if we were solving it, we could find that answer. But in this case, we are going to set up an expression that if we knew all the pieces, we could start solving. If we're looking for the cost of the order, what operation are we going to use to find that cost? multiplication. Multiplication with
The variable.
okay, so yes, we are going to multiply the variables and these numbers together. So let's do that part first. We have 250 teachings. Know that much? What don't we know here? The cost of each. So you can call that variable whatever you want. I'm going to call it K and P. So because we're making up random variables in this world scenario, we have to say what it means. So if I say 250K, off to the side I'm going to say K equals the cost of each.
250 x would be
X would be the cost of each. This represents the number. And then we have 500 pencils, but we don't know the cost of each pencil. Okay, so we have those two. Yes, we were multiplying the variable and that number, Donna. And now we need to add them together to find that total cost. Because once we know how much a keychain costs, then we can multiply it by 250. Once we know the cost of the pencil, we can multiply that by 500, and then we can figure out how much the total cost is. And this, they didn't ask us to find all that, so we're not solving it. They just wanted this piece. I can scan it out for you. Right? Any questions on that? We're going to jump down to number 13.
so that's all we do, right? Is 250K plus 500P.
Mm-hmm. Now later, not in unit 1, but in a later unit, we'll have word problems that we're actually solving. In this case, we're not doing that. We are just trying to figure out what that would be in algebraic expressions. Right, for 13, Mr. Bailey purchased some groceries that cost $B. He paid with a $50 bill. Write an expression for the amount of change he will receive. What's important? It's $50. And
That he pay more than
anything. In this case, they gave us a variable to use, so we don't have to define it. They already did. If he's paying with money and he's getting change, what operation are we using? Subtraction. What are we subtracting?
B from 50. So 50.
Starting with 50, and then however much the groceries cost, I subtract that from my 50. At the end, I can figure out how much change I get. Did it ask us for all that? No, so we don't need to actually do that.
if we were to solve it, how do we know how much
So if we were actually solving it, we wouldn't just have an expression, we have an equation that would tell us like how much change we got, then we could actually figure out. Because we weren't given that information, we can't solve it.
The variable won't go before the.
In this case, no, because if you went to a store and bought groceries but didn't have the amount, you probably have to go work for them for the day. Or not buy any groceries. The 50 goes first because that's how much you serve. Either one is really the same, but we're going to do 14. The volume of a cylinder is pi times the radius r squared multiplied by the height h. Write an expression for the volume. What operation is repeating? I'm sorry, that was the wrong question.
So, we're looking at the volume of the cylinder, we're using pi times the radius, which is our r variable, that is going to be squared.
Yeah, sorry. Let's make some of this.
Multiplied by h.
And we're looking for the volume. So in this, one thing you may or may not know is anytime you see the word is, that means equal with. So this is actually an equation, not an expression, but that's all right. So the volume is, we're just going to call volume V. Volume is, we're just going to use the pi symbol instead of writing out the digits of pi. Pi times the radius, which they say is r, and we're squaring it. And then we're also multiplying that by the height. So if you were thinking about it, this may be how you wrote it out. But you could rewrite this. Since everything is being multiplied together, you don't really need those dots. Here you could also use parentheses, like I could put parentheses around pi and r squared, or r squared and h. It doesn't really matter. Questions on that one? Yes.
Is that the pi signal or an N?
It's supposed to be the pi symbol, but mine never looks like that one, so I just draw like a table. If you can draw like the actual pi symbol, go for it. Okay, there are 2 questions left on this. I'm going to give you till 31 to do those. You may not need that entire time. And then we'll come back and we'll talk about those. Alright, and number 12. First tell me what was important in this. Rena?
The two adult tickets and the 3 students.
Okay. And then what are we looking for? What expression did we come up with? Yeah. Change colors so that sometimes my S's look like 5. We all get something that looks like that. You can change your variables. If you like x and y, that's fine. As long as you tell me what x and y mean. For the last one, what was important here?
That we're finding the area of the triangle. And then that it's 1/2 of the product of the base of the
And what, here we didn't have to define any variables because we already defined. Aubrey?
So I have A
Some of you put BH in parentheses, that's fine. Trying to think of other variations I saw. I don't think it was in this class. In my other class, I definitely saw that. Did you have something different?
I was wondering if A equals BH and divided by Q.
Yes. That's exactly what I was about to write. So that would be the same thing. Basically for what I said earlier, that BH both have invisible ones underneath. So if you wanted to make it all one fraction, either one of these is fine. Right, questions on that? So I'm going to give you guys about 10 minutes to work through problems on the back if you want practice. Last class, we did not, it's not in this. I didn't give you time to practice these, but if you wanted to go back and do these, you can. This page right here that talks about properties. So you'll have 10 minutes to work on that page and the last page. On the last page, I don't think I have this up here. Two of them are inequalities, 7 and 8. If you want to take a guess at them, you're more than welcome to, but you do not need to do 7 and 8. To try the other examples on that and then that properties page. I'll be walking around if you want to check yourself. We will be going over those in class, but the answers to them are on Canvas if you want to check yourself. But so give me like the next 15 minutes, maybe not even that much, of your undivided attention, and then I'll let you grab your phones. Let's see, is this going to let me do this today? You can. Alright, so this is modeling with algebra tiles. You may have used this before, you may have not. But this asks us to model 3x using all of our stuff. You guys can pack up when we get like 6 minutes left. Of these things, there's a 1, there's an x, there's an x squared. Anything in red is negative, so it's the same thing, but these are negative. So if we were trying to model 3x, how would we do that? Sabina? Three of the green rectangles. So if we look, that was correct. So they're saying that this is really 1x. So if I need 3 of them, I would need to bring the 3 down. What would not have been correct is if I did 3 of the 1s and an x. So that would be 3 plus x. So 2 different things. Let's try some more. What about just 3? Cat? 3 of the positive ones?
Yes.
Okay. Six would be the same thing, just 6 positive ones. Super slow. What about negative 3? Gnor? Negative 1 3 times. What about negative 6x? How would we do that one? Avina? So you're saying 6 of these? Okay. Right, so whatever number comes in front of your x, you're just doing whatever it is that many times. I'm trying to skip through some of the easier ones so we can move on to the harder ones, but it's like I can't just skip to the harder ones. Okay. This one says 3x squared minus 3x. Don't tell me all of it. How would I do one part of it? Kat, and then Donovan.
3x squared.
So which one would that be?
Oh, the blue one.
So 3 of my x squares, and then Donovan, how would I do the 3 negative x?
3 negative x.
The green ones. So again, taking whatever number is in front of the symbol, doing that many times. What about negative 4x plus 3? Just give me one part, Abu.
4 means
Now, would they be positive or negative?
negative.
They'd be negative. And then positive 3? Kat?
Plus 3 ones.
3 of just the positive ones. Right, 4x squared minus 2. Go ahead, Naima. 4 of the positive green ones or blue ones? Sorry, I can't hear. And then negative 2. Kat?
2 negative ones.
We're going to get harder ones. There we go. Right? Again, just give me one part. 3x squared minus x plus 2. Kat?
3x squared positive.
Okay. Someone give me another one, Abu.
Negative.
Negative yellow for the negative x or the positive 2?
Negative.
For the negative x. Would that be the yellow or the green? The green. And then positive 2, Abina? Yes.
I have a question. So when we're doing this, does it matter how you line them up or the order of which you drag, or will it just pick up that?
It does not matter the order. If we started with positive 2 and then did 3x squared and then did the minus x, it would rearrange it for you.
Okay. You
When-
just have to get the expressions themselves.
Correct.
Okay.
When we do it in person and you guys have the manipulatives, you can rearrange it how you wish.
Okay. Thank you.
What about this one? Negative 3x squared plus 4x plus 2. Kat, go ahead.
3 negative x squared.
Some whole mouthful.
Yes.
What else? Aubrey?
4x.
4 of the positive x's.
Yep.
And 2. Go ahead, Kat.
2 ones.
Positive ones. I don't think it gets harder than this. Let's do this last one and then I'll let you go grab your phones. Negative 4x squared minus 3x plus 1. Avina. And then Michael.
4 negative x squared.
4 negative x squareds. Michael?
And then 3 positive x's.
Would they be positive or negative?
Positive.
Sure.
Wait, no, shoot.
It's okay. So they'd be negative?
Yeah.
Okay. So just so you see what happens, if I were to put the positive, it would say plus instead of minus. So if you are using this site, just double check that. And then positive 1. Oh, look, we're done. So if you go through all of those, you'll get that little message. We will use this site like now and then later again when we get into factoring. Feel free to go through and play with this if you so wish. There are also others, so when I put this up here, I think you'll get on this site. It'll look like this. Go into using Algebra Tiles, and you can really do any of these. But we're going to talk about more of like terms and combining them next class, how to use them with Algebra Tiles and algebraically. Right? You guys have 11 minutes. You can grab your phones in 1 second. You can grab your phones. You do have one Delta Math. Hold on 1 second. Thank you. You do have one Delta Math that is due by next class. Do it if you have questions before class. Schedule time in my office hours. Come see me. We can go through it together. Or you can email me. I can walk you through an email. If you wanted to work on it for the last 10 minutes, you could do that too. If you have not joined Delta Math, you need to do that today. Anyone have any questions? Is it for just you or for all the classes? Okay. All right. You guys can go grab your phones. Put the calculators back, please.